All right, so let's get started with part one at least. In part one, they're asking you to find the magnitude of the vectors, better known as the, but you can also call it the length of the vectors. Now, the formula that I'm about to show you only works when the vectors has I and j. Now, you notice minus I is the same thing as minus 1i. I just made sure and put in the 1. So to find the magnitude of a vector, you have to take the value touching the I, right? It is called like the coefficient of the I value. So today's coefficient is minus 1. So you take whatever is touching the the I, and you square it. So I make sure I put it in the brackets, plus, this is part of the formula here, the plus, and then you take what's touching j, which is 6, and you also square it. And then you square root afterwards, but you square root last. So if this is pretty simple, you can do this in your head. Minus 1 squared is positive 1, because when you square anything in the world, you get a positive number. And 6 squared is what? 36. So you get 1 plus 36, which is the square root of 37. Now you have, and you put the word units after to get full marks in the exam. Now you have two options here. You can leave your answer in third form, or you could physically square root the 37. You'll get 6.08 or something like that. But I'm going to leave it in third form because obviously third form is more accurate than rounding off the decimal. All right, but don't worry. The examiner is not going to take away any marks for rounding off the 2 decimal places. And I know some of you all are very safe and you try to go to 3 decimal places, which is even better. We can use the same concept for OQ. We want to find the magnitude. So you notice you have a value touching I and a value touching G. So you just do the same procedure. You say 3 squared plus 8 squared, and then you square root last. 3 squared is 9, 8 squared is 64. When you add up those two, you're going to get 73. You can leave it in third form because if you square root 73, you're not going to get a very nice answer. So that's the answer for part 1. We have the magnitude or length of each vector. And once again, this only works for I and j. Now, there are 2 ways you can write this. Well, when it's I and j, you can write it like this. 3, 8, where the top is I and the underneath is j. And for this one, you could have written it like this also. Minus 1 and 6. The I goes on top, the j value goes underneath. All right. So moving on to the next part of the question, they want you to find the angle POQ. It's always the middle letter. POQ. That's this angle they want you to find. So whenever they want you to find an angle, pretend you are standing up by the angle and pretend it have 2 cars racing out from that point. So the first car going from O to P and the next car going from O to Q. The direction is very, very important because believe me, OP is not the same thing as PO. Those are 2 completely different what? Vectors. But lucky for us, it's OP and OQ, which is the exact vectors we have on the screen. So to find the angle in between a vector, right? So we want to find angle POQ. You have to take the magnitude of OP, which we have here already, right? The magnitude. Oh, sorry. Made a small mistake here. The formula is the dot product of OP and OQ divided by the magnitude of OP multiplied by the magnitude of OQ, right? And you have to, well, sorry, you have to cost inverse this answer here. So sorry about that. But go ahead and use the formula for those of you who are a little confused, right? Part 2, the angle POQ is equal to the cos inverse of this, right? So get started. Your job is just to find the dot product of OP and OQ, and you already have what? The magnitude of each vector. Videsh, you have an answer ready. All right, so for the dot product, I worked it out here. Remember, you're multiplying the I values and then you're multiplying the J values, right? So, and you notice the final answer for the dot product does not have an I and a J in it. It doesn't, right? So from here now, it's cos inverse, and let's put in what we have here. The dot product of OP and OQ gave us 45. So we can throw away the top and put 45. We have the magnitude of OP, which is the square root of 37. And the magnitude of OQ is, well, the square root of 73. So this is a matter of just working it out on your calculator. You take 45 and divide it. Well, you all can more than work this out on your calculator. And whatever you get, cos inverse it afterwards. Do the calculation in the brackets first. Put it to 3 decimal places if you wish, and then cos inverse it. Right? So I've seen some answers coming up. I have no idea what the answer is. Right? I'll figure out what we get in that brackets first. In the brackets, I'm getting this, but if I have it wrong, feel free to correct me. 0.86, if I go to 3 decimal places, 0.866, somewhere around that. And then when I cos inverse it, right, second function, cosine 0.866, right, I'm getting roughly 30 degrees, right? Well, if I use 0.866, some of you all might use the entire decimal, all the decimal points, but based on what I have on the screen here, I am getting 30.00, which is basically 30 degrees. So if you are getting a little more than 30, don't change your answer. Okay. Right. So what else do we know about part 3? Well, for part 3, we just learned that the length from O to P is 37 units. And we also learned that from O to Q is 73 units. Okay? They want you now to find the area of this triangle. This question is not add maths from this point. It's regular, boring maths. So use your regular, boring math skills to figure out the area of that triangle. You'll remember from maths that if you wanted to find the area of a triangle, it have a couple of different formulas you could use, right? You could say base by vertical height divided by 2, but that won't be applicable here because we might have something resembling the base, but we definitely do not have the vertical height. But recall this formula. The area of a triangle, you can also use this. A half AB sine capital C. You all remember that on the formula sheet, where A and B are the 2 given sides, the 2 given lengths of the triangle. Don't we have 2 lengths here? That's the common A and the common B. So you could probably call this common A and common B. Multiply by sine C. Now, sine, the angle C, sorry, is the angle in between the 2 sides. That angle must be positioned in between the 2 sides. Lucky for us, look where this 30 degrees is. It's in between the 2 sides we have. So you just have to substitute in the values. You have the value of A, you have the value of B, and capital C, this C here is 30. Right, so Marie, correct. Kaylon, correct. So this is basically what you're typing in. right? Amaya, check it back. Typing this whole thing straight on the calculator. Please don't forget to press the sign button, right? Try it back, and you'll get something like 12.99, very, very close to 13 units squared. Obviously, if you get 12.99, you are free to put your 12.99. So keep trying it, guys, until you get this on your calculator. Great. I'll give you a couple of minutes, not a couple of minutes, 1 minute to confirm everything. Get this up. So what we have to do here is choose one side. I'm going to choose this side here. If I do everything correct, when I'm finished, it will look exactly like the other side. So the first thing I'm going to do, this tan x. Now remember, I just said that tan x is the same thing as sine divided by cos. So I'm going to throw him away and replace him with sine divided by cosine. So let's do that. So we have sine x divided by cosine x, and then this dot means multiply, right? Now, you have a sine x here, but this is obviously the same thing as sine x on 1. So we multiply the top by the top, the underneath by the underneath. And we're obviously going to get sine squared x, and cos by 1 is just cos x. All right, so it still doesn't look like this, but remember the other rule here? This rule, we could transpose it if we want. Let's transpose it. Let's throw across the cos squared x here. So throw across positive cos squared, you get minus cos squared x. This basically means, let me erase it here because we threw it across. Anywhere we see sine squared x, if we wish, we could throw it away and replace them with what? 1 minus cos squared x. How lucky of us. We have a sine squared x here. So let's throw him away. We're going to replace him with 1 minus cos squared x. And this whole thing is divided by what? Cos x. Remember, you have one big divide sign here. So this really means everybody on top at the same point in time get divided by the denominator, which is cos x. So let's write it back like this. The 1 gets divided by cos x, and the cos squared x also gets divided by cos x. Won't this cos x cancel out with this squared? Because you have cos squared on top, that's cos x by our next cos x. Didn't we get the exact same thing here? Look at it. We ended up with 1 divided by cos x, and on top we have minus cos x. So that's the answer there, right? So in case you never already did a proof question before, all you're doing is choosing one side of the equal sign and use the rules which we need to learn off and apply it to that side and keep modifying it until it changes and looks like the other side, right? So for those who are finished, well, you're going to have a lot of problems with part 2. Right? Someone asked how I got the sine squared x. Don't I have a sine x here and a next sine x here? And this is a multiply. Sine x multiplied by a next sine x is sine squared x. All right, so over here, they're saying cos x is minus 24 over 25. And they are saying it's a reflex angle. Remember, a reflex angle, well, it is always spin in an anti-clockwise direction when you're doing these questions. So the first sector is 1, this is sector 2, this is sector 3, and this one is sector 4. So here's 90 degrees, 180, 270, and 360. So they said it's a reflex angle. So that means it's between 180 and 360. So that means it's either we are talking about quadrant 3 or we are talking about quadrant 4. I want you all to tell me which one we are referring to. We narrow it down to 3 and 4, but we have to be more specific now. Is it 3 or is it 4? Jail, correct. Khalil, correct. Boy, Marie, correct. And I'll take one more answer. Kaelan, correct. We're talking about quadrant 3 because in quadrant 4, cosine is positive. But look at the value of cosine here. It's negative 24 and 25. So in quadrant 3, only tan is positive. That means everybody else is negative. So we're talking about quadrant 3. Now I just want you to pretend this is an X and a Y axis, right? So if this is our X-axis and this is our Y-axis, we know everything above will be positive because we have positive values here. Everything on this side of the X-axis is positive. Anything behind is negative, and anything below here is negative. So when we draw the triangle today, because remember, sine, tan, and cosine are only for right angle triangles. This is the triangle you need to draw. Right? We use different colors here, so make it easy to communicate. Right. So that means this green line is below the x-axis. So it's on the negative portion of the y-axis, okay? So this green line, whenever if you have to calculate any values or anything, whatever value you get, make sure and afterwards put a negative sign. Also, this purple line here, that is definitely on the negative part of the x-axis. So whenever we do calculations or whatever, even if we get a positive value, we're going to put a negative. The hypotenuse of the right angle triangle, no matter what, is always positive. The hypotenuse is positive, whether he's below the x-axis, whether he's above the x-axis, he doesn't cater. He always positive. So let me just help you out a little bit here. So the examiner told us cos A is equal to minus 24 over 25, all right? So that means the minus sign could either be on top or the minus sign could be underneath. We're going to figure out where the minus sign goes just now. Remember from normal maths, cos is what? Adjacent divided by hypotenuse. Where do you think the negative sign belongs? On top or underneath? From what we just discussed. Well, where do you think that negative sign belongs? Okay, Kaelan, correct? Anybody else want to take a guess? Because we have a negative sign to put in here, right? We just can't leave out the negative sign. Cos is adjacent divided by hypotenuse. Marie, correct. Anybody else? One more guess? It's not a trick question. It's really not a trick question. Khalil, correct. Right. It belongs on top because we now said the hypotenuse is always positive. Okay. So if this is the angle A they are talking about, right? The angle A, the angle that they're always talking about is the one touching the origin, right? Not this angle here. So cos is what? Adjacent divided by hypotenuse. The adjacent is minus 24. Remember, it's below the x-axis. And the length of the hypotenuse is 25. You think you all could find the length of this side for me using Pythagoras Theorem? Remember, in these types of questions, even though I have a negative length here, don't let the negative sign bother you. When you're using Pythagoras Theorem, you just ignore this minus sign, do your calculations as normal, and when you get your answer over here, because it's on the negative portion of the x-axis, you just add in the minus sign after your calculations. All right, so use Pythagoras Theorem to find the length of this line here. So I'll give it some time. Guys, I made a small mistake here. Jail pointed it out. Remember, cos is what? Adjacent over hypotenuse. Anybody else see the error I made? If I'm standing here, isn't the adjacent side over here? So here's supposed to be the minus 24. So we are trying to find the length of this line. My mistake, guys. All right, but it's still not going to change your answer, your final answer. We're still finding the length of this side, but you're going to get the same answer anyway, right? So it's not going to affect much in any case. Right, so thanks for that. Right, so am I correct? Now, when you use Pythagoras theorem, it's going to be 25 squared minus 24 squared square roots, okay? I'm not going to go through too much with Pythagoras theorem, but when you find the length of this side, you're going to get 7, right? You notice it's less than 25, but because it's below the x-axis, we have to put minus 7 on the diagram. So the next part, to finish this question now, they want us to find tan A. So run out of space here, so let me get a different color. Isn't tan A opposite over adjacent? So if we're standing at A, how much is the opposite side? The opposite side is minus 7, and the adjacent is minus 24, right? 2 minus will give you a positive. That's the final answer. Positive 7 divided by 24. All right? So what we have to do is replace the item in brackets with the letter U. So letter U, let it represent 2x plus 3. So that means, if we get some space here, throw away the item in the brackets and then replace with the letter U, and we have it to the power 2/3. So we have two expressions, one with U and X and one with Y and U. So let's just differentiate each expression here and see what we get. We differentiate U and X, with U being the subject, it will be du dx. When you differentiate this, you're only going to get 2. All right, when you differentiate a constant, you get 0. And anything touching plain old boring X, when you differentiate it, you are just left with the constant. Y and U, if you differentiate it, you get dy du. You throw the power in front, and you minus 1 from the power. 2/3 minus 1 is minus 1/3. All we have to do is throw it into this formula now, right? So to find dy dx, which is what we want to find, we just have to take dy du, which we have, I think we have it here, look at here, which is 2/3 u to the power minus 1/3 du dx. Where is that? Where is that? That's 2. We multiply these two, and we basically almost finished there. So this 2 can multiply with this 2 on top. So you'll get 4 on 3, u minus 1/3. However, we were the ones who came up with the letter u could be represented by 2x plus 3. So remember, at the end of the question, throw away the u now and replace it with the 2x plus 3. And don't forget to the power minus 1/3. How much of you all had that on your end? Including the 4 on top here, right? I don't think it's good practice to leave the 2 on this side and a 2/3 on this side. You might as well multiply it, right? There's also a shortcut method, but this is just my advice. The CSEC questions like this are set up for the chain rule. And I think the examiner would like to see the chain rule being used. All right, so that's just my advice. I know some of you can just do it in your head and use the shortcut method, but I really advise against that if you want full marks. Let's see where you reach, right? So I think we established the quotient rule already. The u and v, the top is always u, the underneath is always v. Differentiate du dx. You're going to get 6x squared. And underneath, you're going to get 2. Everybody got that so far? With the du dx and dv dx. And all we have to do now is just throw it into the formula. I'm not too sure how messy this is going to look. Right? V is 2x plus 1. Du dx is 6x squared minus, for u is 2x cubed plus 2, and dv dx is 2. And this whole thing is just divided by v squared. So I guess from this point, it just try our best to simplify it for the examiner, right? So that's gonna try here. I'm not too sure how much simpler it's gonna get. Right? Multiply everybody inside here by 6x squared. So 2x by 6x squared is 12x cubed plus 6x squared. And then now we have a minus sign here and it have a 2. So everybody gets multiplied by 2 and also a minus sign. Right? I'm not going to expand the brackets underneath. That will not make it any simpler. That will just make it look worse. Right? I think I almost finished here. 12x cubed minus 4x cubed is 8x cubed plus 6x squared minus 4. Right, so that's what I have so far. Right. All right, so let's give you a little jump start here. The first thing, whenever they start to talk about maximum and minimum, you know it's differentiation. So you're going to differentiate once, dy dx, and of course you get 6x squared minus 42x plus 60. What we need to do now is put this equal to 0 and solve, well, we have a quadratic. So when you solve the quadratic, you're going to get most likely two values for x. But the thing about it, when we get those two values for x, we don't know which one creates a maximum and we don't know which one creates a minimum. All we know is it could either be a maximum or a minimum. To sort that out, to figure out which one is a maximum or a minimum, we will have to differentiate one more time. But at least solve this quadratic for me, right? And let me know what you get for your two values of x. Already. When you solve it, you're going to get 5 and 2 when you solve the quadratic. Now, from this point, we need to figure out which one is the maximum or the minimum, which means we have to differentiate one more time. So this red expression here, differentiated one more time, you will get 12x minus 42. Throw the values of x in here one by one. So replace this x with 5, work it out. If you get a positive number, it's a maximum. If you get a negative number, it's a, so I say wrong, sir. If you get a positive number, it's a minimum. And if you get a negative number, it's a maximum. Right, so when you replace the 5 inside here, let me know what you get. Then replace it with 2. Okay. I think this one will give you a positive. And from just looking at these values, I think you will get a negative, but you confirm it. All right, so positive 18 and minus 18. So since the 5 gave us a positive number, here's a minimum. And since the 2 give us a negative, here's the maximum. Now let's look at the question. The question is asking to determine the minimum. So that means we don't care about the 2 today. We only care about the x being 5. Now here's the thing, right? A lot of people will stop the question there because they say, hey, the x is a minimum. But this value of 5 will give you a minimum. But we didn't actually get the minimum. We just know if we use x as 5 on the graph, at that point, there will be a minimum. To get the actual minimum value, you go to the original equation and you replace all the x's you see now with 5. Okay, so you have to replace this x, this x, this x, and work out that whole thing. Then you get the actual minimum value. Part C is trying to figure out if you know the difference between distance and displacement. Okay, so let's try to draw this up. So you have a motorist apparently at point X or something like that, right? So you call this dot point X. And he travels 10 meters north. So not 10, 100. So he moves 100 this way. That's the green arrow, right? 100 meters. And it takes how much seconds? 20 seconds. So I'll just put the 20s here. So know that he takes 20 seconds to do that. He stays there for 40 seconds. So at this point, for whatever reason, he remains put at that point for 40 seconds. So far, 60 seconds gone. 20 seconds to reach the location and 40 seconds waiting at the location. Then apparently he decides to go how much meters south? 200 meters south. So from here now, remember he's continuing the journey and he goes 200 meters. Now, obviously this is 100 meters all the way back. So this here is 100, right? All the way back. And how much would this distance be? This would also be what? 100. But here's the thing, this distance here, or displacement, is, sorry, I'll give away the answer. Send the answer for part 1. Determine the total displacement for part 1. The answer is on the board there. It's just trying to figure out if you know the difference between distance and displacement. If I ask you what's the distance moved, the answer would be 300, right? 100, 200, 300. That's the distance. But if I ask you what's the displacement, you see, displacement is like a vector quantity. When you go one direction, it's positive, and when you go the other direction, it's negative. You notice, so when you're on this side of X, it's positive. So that means the displacement, since your final position is on the other side of X, the displacement is actually minus 100 meters, not 100 meters. And remember, displacement is the distance from the starting position. But if it's on the other side of the starting position, because we claiming this side is positive, so anything behind that point, we have to view it as negative. So that's the actual answer for part 1, minus 100 meters. Calculate the average velocity. Now, the average velocity is a simple question. Remember in maths class right now, we're doing average speed. Now, let me tell you the difference. Average speed, if they ask you, is the total distance, look at the words they're using, over the total time. So if they ask you for the average speed, by the way, how long does this thing take? 20 seconds to go back, right? So everybody agrees that the total time is how much? 20 plus 40, which is 60, plus, how much is the total time there? 20, that's 60, 80. Everybody agrees that the total time is 80, right? Let me just make sure on that. The total time is 80 seconds to go on here. So it's 80 seconds. So if they ask you for the average speed, the total distance would be 300 divided by what? The total time, which is 80. But they didn't ask you what's the total speed. They ask you for the total what? Velocity. When it comes to velocity, velocity and distance doesn't go together. Velocity and displacement is friends. So the answer for this one would not be 300 divided by 80. It would be minus 100 divided by 80. So your velocity actually ended up being negative, which is possible, right? So divide these two, well, I could do that, right? 100 divided by 80 is minus 1.25 meters per second. And I put my correct units and everything, right? So I'm saying it again, speed and distance is friends, but velocity and displacement are friends. First of all, well, in case you can't remember, pi on 2 is the same thing as 90 degrees. So you don't already have to switch your calculator to radians mode, right? So when you're integrating cosine, but when you're integrating cosine, you just get positive sign. And whatever is touching the x here goes underneath. So I don't know if you all got this, right? So you'll get 2 sine 4x, but the 4 also goes underneath here on the outside. So it have a 2 weight in there, so the 4 just goes underneath that. And it's the same concept here. The examiner kind of made it easy. 2 sine 8x, and of course the 8 goes underneath. Obviously 2 on 4 could simplify and 2 on 8 could simplify. But after you do that, you put your little square brackets, 90 and 0. So you know you replace both x's here with 90 and then both x's here with 0, and you minus both answers. Take it from there. All right, so on the screen here, we know what we do in replacing all the x's here with 90. Look, I have it over here in blue. When we work this out for the top one, we get 0. Then we replace all the x's with 0, 0.5, but you'll get 0 here minus a next 0. So for both of them, you get 0. So the two answers you get, you're supposed to minus them. Now 0 minus 0 is 0. So the final answer is 0. Right? So a lot of work to get 0, right? But that's how the question came. All right, part B, let's do that. That will be the last question of today. Right, no problem, Khalil. Part B there. In case you need the formula for volume, I will put it on the screen here, right? To find volume, it's, trying to remember, it's pi or 2 pi. I think it's pi y squared dx, and your two limits go here. All right, so what you need to do here, right? It's a matter of just putting the two limits here. They told you it's 1 and 3, and you're integrating y squared. Remember, y is 3 divided by x squared, but we have to square that. So if you square this, you'll get 3 on x squared, and the whole thing is squared. 3 squared is 9. X squared is x to the power 4. Now, when I am integrating, I'm going to put that here eventually. But when I am integrating, I really don't like it when the x is underneath. My advice is to make sure and throw it on top. So you get x to the power minus 4. So this is what you are essentially integrating. 9x to the power minus 4. Right? So do your best to integrate this. You add 1 to the power, you divide by the new power, and so forth. So we know we have to add 1 to the power. So let's do that. We add 1 to the power, we get minus 3, and then we divide by the new power. So it's 9 minus 3 divided by the new power. I will simplify that as much as I can just now. 9 divided by minus 3 is, well, minus 3. And I really don't like how I have this x to the power minus 3. So I just going to throw it underneath, and the power is going to become positive, sorry. How much of you all had up to there, right? Like you could safely say you had either the thing on top or the item underneath. Right, so Nadia had it, Amaya, Soda, right. So what you have to do is substitute in the 3 now and substitute in the 1, and you're minusing your answer. So you have to take your time. I know this minus sign here is going to tie up a lot of you all. Right, so throw in the 3 here, minus, because we have to minus both answers. But we have a next minus 3 here. Right, so I just kind of, so easy to make a mistake with these minus signs. Right, so again, minus 3 divided by positive 27, a minus and a minus is a plus. Well, 1 to the power 3 is 3. 3 divided by 3 is 3. And a minus is a positive. So that is what you're getting there. So I'm going to use my fractions button to add up that. When you use your fractions button, you will get 2 and 8/9. And don't forget you have pi waiting here, pi units squared, because the integration will give us the area. Yeah, you all confirm this. I remember I kind of rushing it on my end, and you all have seen I've made 2 errors for the day already. So you make sure you physically come up with this on your calculator. Right? And once you get it and confirm it, that's the end of class, and you are free to leave, but please confirm before you leave. The units is supposed to be units cubed because it's volume, so that's my error.